All right, we're going to do the same thing, ask the same kind of questions we did as in the previous video, but we have a more difficult graph of a function. Now we can see that this is a function. It passes the vertical line test. Any vertical line I care to draw only intersects it at most once. What's f evaluated at -1? Okay. So what we're going to do is we're going to find the point whose x-coordinate is -1. That's the point whose x-coordinate is -1. I can see that its y-coordinate is 3. So what does f do? Well, it maps -1 into 3. And so the answer to that question, f evaluated at -1 is equal to 3. What's f evaluated at -3? You find the point whose x-coordinate is -3. Now, when I look up, there's nothing. When I look down, there's nothing. So this is not defined. I'm going to change the graph of this just briefly. This is still the graph of a function, isn't it? Because any vertical line doesn't hit it at all. Once, 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 not at all, not at all, once, 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 not at all, once, once, and then once. Because it goes through there. It does not go through that point. Okay. So what if we had been asked, what is f evaluated at -5? Well, you find the point whose x-coordinate is -5. So I look at -5. There's not a point there or anywhere else, but when I look down here, there is the point. So -5, comma, -2 is on the graph. And so f maps -5 into -2. And so the answer to this is -2. That's the answer. The point is not the answer. -2 is the answer. Okay. What's f evaluated at 4? I look for the point whose x-coordinate is 4. And it's 4, 1. And so f will map the x-coordinate 4 into the y-coordinate 1. So the answer to that is 1. What's f of -4? I look for the point whose x-coordinate is -4. Its y-coordinate will be f of the x-coordinate. So that point is -4, 4. So f maps -4 into +4. Is f of 6 a positive or a negative number? I find the point whose x-coordinate is 6. There it is. So what is f of 6? Well, it will be -3, but it didn't ask me for f of 6. It just wanted to know, is f of 6 positive or negative? So it's negative. When does f of x equal 1? F of x is the same thing as y. So when does the y-coordinate equal 1? That's the same question. So here's a y-coordinate. Here's the y-axis. There's 1. And the y-coordinate is equal to 1 when x is equal to 4. That's our answer, when x is equal to 4. When does f of x equal 3? When is the y-coordinate 3? So here's 3 on the y-axis. That point is not there, so that doesn't count. But what points have y-coordinate 3? All of these points. So what can we say about them? The y-coordinate will equal 3 when the x-coordinate is between -2 and -1 inclusive, because we don't have any hollowed out dots. So when does f of x equal 3? When is the y-coordinate equal to 3? When the x-coordinate is in the interval from -2 to -1. Or you could have written that. That would have been correct too. But that's how you would see it. How often does the line y equal 4 intersect the graph? What does the line y equal 4 look like? It's the horizontal line that goes through 4 on the y-axis. How many times does that intersect the graph? 1, 2, and no more. 2 times. What is the domain? The domain is the set of x values that are allowed. So I'm going to use the x-axis to measure how wide this is. We start out but do not include x equals -5. Oh, sorry, we do include because it's there. So I will start out at -5, and I include it because I do have a point whose x-coordinate is -5. Then when I get to the right of -5, I have points on this. So I'm going to do it like the number line. And I keep going until I get to -3, and there is no point with x-coordinate -3. So I'm trying to draw the domain here as a number line. So what are x values are permitted? Then after I get to the right of -3, I have points on the graph until x is equal to -1. And I include -1 because I've got that point. Okay, and then I don't have any points on the graph, and then I pick it up again when x is 2. And then I have points up until x is equal to 7. I do not include 7. There are no more points on the graph. That's all right. Be about there. That's where 7 would be. Okay, so that's a good representation. I'm using the x-axis like a number line to try and measure how wide this thing is, and I have to leave out any gaps. So that's what x values are allowed, everything in red. But we will be required to write that in interval form. So going from left to right, I start at -5, I include it. And I have points until I get to -3, and I have to skip over -3. Then I have points between -3 and -1. I include -1. Then I have a gap. I pick it up again at 2, and I include 2. And then anything up to but not including 7. In the red, that is the domain. What about the range? The range, we use the y-axis to measure how tall. So where's the bottommost point? Well, if that one was there, it would be there. So we're going to start at -4, but we do not include it. So I'm using the y-axis to measure how tall. And now as I'm going up, if I look right or left and there's a point, I'm fine. There's no gap. And then I get up here to 1, and that point is included because we don't have a hollowed out bullet. But then when I get past 1, if I look right or left, I can't see anything. Okay, so for everything in between -4 and 1, I include 1. And then where do I pick it up again? I pick it up again at 3. True, that point doesn't have a y-coordinate of 3, but all of these do. So I'm going to pick it back up at 3. And then what's the highest? Well, if that were there, that would be my highest, which has a y-coordinate of 5. So it goes all the way up to, but doesn't include 5. Now that's a correct way to represent the range as a vertical number line, but we need to do that in interval form. So from bottom to top, the range is what your y values are. Y would be from the interval from -4 to 1. We do not include -4. We do include 1. Then I have a gap. And then we pick it up at 3. We include 3. and we don't include 5. Okay, so that's a more difficult one than the previous one, but it answers the same questions. That ends this lecture.